Hello everyone. This video I'm just going to go through section 11.3 of the Statistics and Mechanics book 1 on page 186, and it's on variable acceleration and it's Maxima and Minima problems here. So using the fact that when you find the maximum value of a function or the minimum value of a function, then the derivative of the function is 0. Okay, so we go to here. We're going to look at this problem example 5. The child is playing with a yo-yo. Now, if you don't know what a yo-yo is, here are some pictures of yo-yos. It's a child's toy. You have a circular disc thing here with a string wrapped around it, and you hold the string and the yo-yo descends and it goes up and down the string. I'm sure you all know what one of those are. A child's toy like that. So it's something that goes up and down vertically, and it's not, the acceleration is not constant. The yo-yo leaves the child's hand at time t equals 0 and travels vertically in a straight line before returning to the child's hand. So as it goes up and down all the time. The distance s meters of the yo-yo from the child's hand after t seconds is given by this expression here. S equals 0.6t plus 0.4t squared minus 0.2t cubed when t is between 0 and 3. Now part A says justify the restriction for t to be between 0 and 3. Well, let's have a look. What happens if t is 0? T is 0. S, which is 0.6t plus 0.4t squared minus 0.2t cubed. But if t is 0, s is 0. Let's put that here. T is 0, s is 0. What happens when t is 3? T is 3, s is 0.6 times 3, so that it would be 0.6 times 3. 0.4 times t3 squared, which is 9, minus 0.2 times 27 t3 cubed. So we have 1.8. 9 times 0.4 is 3.6, and 0.2 times 27 is 5.4. So 1.8 plus 3.6 is 5.4, minus 5.4 is 0. And so the displacement is 0 at 0 and 3. Now, if we were to sketch the graph of s against t, where we have s on the y-axis and t on the x-axis, it's a cubic which has a negative t cubed term, so it has that shape, and we know that it passes through t 0, 0, 0 and 0, 3, and so it looks like that. S is distance, s must be positive, t is time, which is positive, and so we only have this little bit here. I'll put that into red. That's the only valid part when t is between 0 and 3. The distance s must be positive, and so t must lie between 0 and 3. Okay, so that's part A. Part B, maximum distance of the yo-yo from the child's hand. So what's happening here? on that graph, the yo-yo descends, so has its distance from the child hand increases up to that point there, and then it goes back to the child's hand at that point, so it's 0 distance from the child's hand. So that is the point where it turns round. And as you can see, that at a maximum, you'll have ds by dt equals 0. So at that point there, ds by dt is the maximum, because it's the gradient is horizontal. So we're using the fact that at a maximum, we're looking for the maximum distance, and at a maximum the derivative is 0. So we need to find the maximum distance. So we have s is 0.6 t plus 0.4 t squared minus 0.2 t cubed. So we differentiate. ds by dt is 0.6 plus 0.4 t squared, so we have 2 times 0.4, which is 0.8 t, and t cubed differentiates to 3t squared, so times by 0.6 gives 2 gives you 0.6 t squared. And then to find the maximum, when s is a maximum, when the distance is a maximum, ds by dt equals 0. So we make that equal to 0, and we'll solve that. Now we can see that we can divide by, well, we can multiply by 10 and divide by 2. That gives me 3 plus 4t minus 3t squared equals 0. Okay, well that's a quadratic. It doesn't factorise. So we'll use the formula. I have to multiply by, if I multiply by minus 1, I'll get 3t squared minus 4t plus 3. That's get a positive t squared, which I can do because I've got an equation. I can multiply both sides by minus 1, so 0 on that side. And t would be minus b, 4 plus or minus the square root of the discriminant. B squared is 16 minus 4ac. I have made a mistake here. Yes, small mistake here. That there should be minus. Oh, sorry. Nope. Wrong again. That was plus. No, so that should be minus there if I multiply by minus 1. So, cross it out. That is minus 3. Okay, so when we do minus 4ac, it becomes plus 4 times 3 is 12, plus 3 times another 3 is 36. Over 2a, which is 2 3s are 6, so that's 4 plus or minus square root of 52 over 6. And the square root of 52 is obviously slightly over 7. 7 squared is 49. So we have the t is positive, so we have t is 4 plus root 52 over 6. 52 is 4 times 13. So that's 4 plus 2 root 13 over 6, dividing by 2, we have 2 plus root 13 over 3. And that is approximately 1.8685. We would then, to find the maximum distance, we would want to substitute that into the expression for s, so s would be 0.6 times 1.8685, plus 0.4 times 1.8685 squared minus 0.2 times 1.865 cubed, and I believe that comes to around about 1.21 meters. Okay, so having gone through that, the next thing to do would be to go back to the book and practice finding maximum and minimum values by doing exercise 11C here on page 187. 11C, which has 6 questions. Do as many as you can. The important ones to do, 5 and 6 here. Exam and problem, that stands for, and those are the most challenging ones. In the next video, we'll look at using integration.